what's going on here. Today's topic is going to be about multicast, and this is one of those things that is one of those like unknowns, you know, like a lot of people who are getting into the networking realm because of NDI, they hear the word, but they don't really know what's all entailed. And so today, with the help of Jake and a few other things, we're going to talk about what multicast is generally, and then we're going to talk about how it behaves with NDI, but then also tangibly, you know, I'll use one of my own cameras, and we'll talk about how to actually set that up and use a multicast configuration for a BirdDog product and what that actually looks like. So I want to be sure that we're spending a little bit of time, but I also want to be absolutely sure that you kind of have a general idea as to what it is and why it plays a role in large NDI rollouts. Now, as a kind of a bookend conversation here, we've already talked about two styles of networking. We talked about in part 1, which is available on the BirdDogJake YouTube page. We've talked about static networks and how to actually do it, okay? They're not my favorite. I think we all know that. But static networks is a way that you can actually get NDI up and running fairly quickly. There are some things, some gotchas or some catches that you need to consider, and in particular, you need to know what discovery server is and how to implement it. So if you're doing static, you probably need to, actually not probably, you need to run a discovery server so that you have consistent performance across the fleet. Now, if that option is off the table and you need this to function without exterior services running, then you're automatically already talking about DHCP, which was part 2 of this series, where we talked about DHCP services, how they work, why you want them, what MDNS is, you know, what routing tables are, and how to kind of configure all of that. So we go through that. We talk about why DHCP services are how we feel they're superior in many regards, and why you might want to use that instead of a static, especially if you're starting from scratch. There are it's basically you learn one or the other, and I would strongly recommend for NDI purposes, you learn how to implement DHCP, and they make it super easy on the Netgear 4250 line. And so if you're getting into NDI and you're getting into AV over IP, you're going to probably be looking at the 4350 line anyways, because the 4250 line, because those are the small to mid-size NDI installation options. And if you're looking to do something on a large scale, the brand new announced 4350 line is the same interface, but it's a very strong backplane for data to be processed. And so you want to, if you're serious about doing video over IP, you're probably looking at AV over IP switches to begin with, and Netgear is clearly out in front in many of those regards. So the third element to this, part 3, is really about multicast and what is it and how does it work. Multicast answers the question about what to do when we're sending one endpoint to multiple destinations, okay? Because in the NDI realm, when you make a connection in the unicast world, okay, so TCP or RUDP or UDP, you're making a connection between a BirdDog camera and a BirdDog decoder. Let's just keep it straightforward and simple. That full NDI stream is going to be running, for HD, is going to be running somewhere in the ballpark of 140 megs. And so you're taking 140 megs and you're subscribing to that stream. Okay, so our camera's on the network. It is doing its thing, but nobody's subscribed to that camera. You're taking that and subscribing to that stream, and the network is going to make the connection between the camera and the endpoint, the decoder, and it's going to start streaming 140 megs. Well, that's all well and good, except what if I open Studio Monitor on a computer as well? Okay, well, now we're going to send it from the BirdDog camera to the decoder, flex out, but then we're also going to subscribe to that stream from the camera to Studio Monitor. And then what if in Studio Monitor, I'm like, okay, now I need to open vMix. And so I open a program like vMix, which subscribes to the cameras again. And so we have 140 megs going to the flex out. We've got 140 megs going to the Studio Monitor. And now we've got 140 megs also coming in for vMix. Well, that's starting to pile up, right? Multicast answers that problem because Multicast puts the onus of the subscription on the network, meaning that the packets, once they enter the network, do not stack on top of each other, but instead are only replicated at the point of subscription, meaning that the decoder, the flex out in this instance, the flex out asks the network to subscribe to that multicast stream, and that multicast stream is only then replicated at the endpoint, meaning the data's on the network in 140 megs, but it's not sending 140 plus 140 plus 140. It's just 140. Okay, so we only have 140 megs per HD full NDI stream on the actual network, and we're not duplicating. We're not causing it to go to 280 and 360 and so on and so on. It's just going to be 140 megs, which means that now I can set up not one decoder, but 10 decoders, and it's only going to cost my network 140 megs. It's only going to have to process 140 megs per subscription. So Unicast puts the onus on the actual endpoint to subscribe and makes the endpoint and the actual encoder get that stream going. And in smaller networks, okay, if you're new to networking, 300, 400, 500 megs of constant throughput is pretty much all mid-size switches can do. All right, so we need to understand that although the marketing says that my 24-port 1 gig switch says that it has a backplane of 24 gigs, all that is the peak performance of every single port on that switch put into a calculator, and they typed in 24 times 1 gig, and it came out 24 gigs. That's what the marketing team did, okay? But what they didn't tell you is how much data the actual silicone can process. And that's different, okay? So there's usually an onboard processor, there's usually onboard memory, there's usually onboard, well, various things, but there's a packet buffer and a few other things that are actually functioning on the switch. How much data can this switch actually process at once? Because once we hit that threshold, that's going to start dumping packets into the packet buffer, and that buffer will never empty because it'll never be able to catch up. And eventually, what will happen, right? You all know this story. The buffer gets full, it dumps all the data, and you see a drop frame, or you see a skip in your video. All of your video skips, or some of them skip, or some of them jitter, or whatever you want to call it. But you see something that would be undesirable in a live video situation. So Multicast fixes that issue because it basically doesn't overload the switch because it's doing multiple subscriptions. You can load the switch up with encoders, with NDI signals, and then send them across to multiple destinations. Now, again, in a practical sense, how many decoders are we talking about here? Well, this becomes more of a problem when we start dealing with inexpensive decoders like the BirdDog Play or Flex Out or Mini, where these units are functioning in decode mode and they are showing this on televisions in hallways from a conference center, or they're sending this signal to multiple places around campus. That's when Multicast really shines, because now, again, it's only 140 megs per HD stream. So when do you start talking about Multicast? Well, when you're probably receiving a single source more than 4 or 5 times. Because if you get to 5 times 140 is not a small number. And more than likely, your mid-level switches are probably not going to be able to handle that amount of data, especially if on a consistent, long-term installation. If you were firing this up and you were running this over a short term, you're just doing something fast, you probably get away with it. All right. But if you're doing this and you're setting this up as an install for a client, or you're doing this on a bigger level, that is probably not going to work very well. So that's the concept of Multicast with kind of NDI. Now, there are ways in the Unicast realm to also achieve this goal, where you could do what's known as a broadcast, right? So the broadcast would do a broadcast style of packet transmission would also do this, would achieve this same goal. But with every device that's on the network, it would basically mean that the network has to handle every single one of those packets. And so that's that Unicast idea, is the network has to handle every single packet and has to make sure that they all arrive to the destination intact and with enough overhead to process the next one coming. And again, when we're going to multiple destinations, multicast is really going to be that answer, because we want to be able to leverage the ability for the network to handle this data in a different way. All right. How does multicast actually do this? Okay. Now, I'm not going to get into the nitty-gritty of how it arrives at the switch level, okay, because it actually arrives with a multicast address to it, and when the device subscribes to it, there is the multicast address is not registered in the routing table. All right, this is all going to be kind of this is a little bit outside of where I wanted to go here, but that is not going to be registered to the routing table. And so what happens is the multicast address, okay, so the 4-octet address gets translated into basically a MAC address, and it gets then subscribed to from the decoder to the MAC address. So then the switch kind of understands what's going on. Now, there are a couple other concepts that I'm not going to get into, because there are various ways of configuring this, and this goes beyond what you need to actually understand when we're talking about 4250s and multicast. But the layer 2 level of it is IGMP. Okay, so you're going to hear that term thrown around a little bit. And IGMP is what enables, IGMP snooping in particular, is what enables the switch to learn the multicast MAC addresses of devices. Okay? So when you enable multicast on your network, you're going to hear, or you're going to see in the multicast guides, you need to enable IGMP snooping on the switches. This IGMP is a layer 2 function of the switch, whereas PIM, which is another, again, item that you probably don't need to know too much about here in this instance, but PIM is layer 3, and this is going to be at the switch router level. And PIM, depending on what you pick, again, you don't have to do this with 4250s. That's what we're going to talk about that. But depending on the style of PIM that you use, dense or otherwise, this will inform the switches of how to navigate the network. Okay, so how multicast packets actually navigate the network. So that's layer 3. So PIM is what you need to know for this conversation is PIM is layer 3, and PIM informs the network how the packets actually construct the pathways across the network. Okay, and then IGMP and IGMP snooping is a layer 2 function, and that's happening and informing the switch who is who in the multicast realm. Okay, that's what's going on. So you're going to see in the instructions, if you're not using a 4250 and you're asking, how do I set up multicast? The installers, BirdDog, all these sorts of guys are going to say you have to enable IGMP snooping on the switch, because that informs the switch who is who. It informs the routing table who is who in the multicast realm. Okay, so that's why that's a requirement. So router level is layer 3. Okay, switching level is layer 2. And so the IGMP thing is happening on the switch level, and PIM is happening on the router level, which is informing the router how to actually route the data. Okay. By default, this is important, by default, the MAC address doesn't exist on the actual routing table. So here's why you need to know this. When a multicast packet arrives, when a multicast request, subscription request comes to the switch is going to see the MAC address. And if IGMP snooping is not enabled on the switch, it's not going to know what to do with this MAC address, and it's not going to be registered to the routing table. And so what does it do? It doesn't dump it. It sends that information out every single port. So if IGMP snooping, for example, is not enabled on the switch, what it does is it sends the multicast information out every port, which defeats the purpose of multicast. Okay? It replicates all of it. And then it means that the endpoint, whatever it is, a VoIP phone, a computer, a BirdDog camera, a BirdDog decoder, whatever is on that port, it's up to that to discard that packet, which actually does take processing power, by the way. So it's up to the endpoint to discard the packet at the NIC level, at the actual interface of the computer to the network. So if IGMP snooping is not enabled, when that MAC address request arrives at the switch and the switch doesn't know who to give this to, it says, I'll just give it to everybody. And it shoots it out all of the ports. With IGMP snooping enabled on the switch, the switch starts to learn who's who, where, like what MAC addresses are associated with what, what devices. And then when the request comes in to subscribe to a multicast stream, the switch knows, oh, that guy's asking for this MAC address stream, and will make the connection and not send it out every port. And that is where the leverage of multicast starts to shine, because not only does the switch understand where everything is, but then it's only sending that replicated packet of the 140 meg NDI stream out that one port. Okay, so it's highly efficient in terms of how it is that we actually structure our networks. But that's why IGMP snooping is so important on the switch level, on the layer 2 level. So that needs to be enabled in order for us to actually leverage the advantage of multicast. So when the destination sends in the subscription request, the switch is going to learn the actual MAC address of the device, of the stream, and then it can specifically tell you, or it can send that specific stream out that specific port. And that is why that's super important. Now, in the multicast realm, multicast packets are traditionally UDP, meaning that they do not care if they made it or not. Okay? Remember from networking conversations before, and maybe you're new to the show. Welcome to the show, by the way. Remember from conversations before, traditionally, TCP is a handshake. It's the packet gets sent out, and the receiver receives the TCP and sends back a response and says, I got that one, send the next one. And it's happening at lightning speed. UDP is basically me throwing the packet over a wall and saying, hope somebody's over there to catch it. But the reason why UDP shines with multicast is because the network is there to make sure that the subscriptions are correct. It also, by the way, enables the leverage of it uses the processing power and leverages the sophistication of a well-orchestrated network to get the packet from encoder to destination effectively, on time, intact, in sequence. That's really important, but without any sort of degradation to the actual packet itself. And so it's up to the network to make sure that that subscribed multicast stream is done correctly, efficiently. And if it's not, the network can figure out how to route that data better. Okay? So the layer 3 level, which was that PIM level, it can figure out more efficient pathways. Maybe that means it goes through less busy switches on your network. Maybe that means it takes the trunk path instead of the alternative connection, or however it is that you're set up. The actual PIM level, the layer 3, the routing level, will determine the best path forward, and sometimes that's not the shortest. Sometimes it's the fastest, and you would hope that generally it would always be the fastest in this regard. So it's important to understand why the different things are set up the way that they are, because your network in the multicast world will learn the most effective ways to send that data across the network. And then the switches will learn who's requesting and what needs to go where. And if you can get to that level, even in a small, maybe I shouldn't say this, even in a small network environment, multicast is incredibly efficient. And it means that if you are running multicast, you can expand very quickly and efficiently without losing performance. Your bottleneck will be the actual processing power of your network. And so keep that in mind as you expand your products in a multicast configuration, adding more BirdDog plays, or you're adding more flex outs, and you're putting them in this multicast configuration. The bottleneck will eventually be the ability for the network to process this data. And whether you're going back to a fiber core, maybe the core gets upgraded to a 4300. Okay. If you're going back to a 4250 core and you want to move, I don't know, does the 4350 line have a fiber core model? I don't know. I haven't looked. I'll check it out. But you need to upgrade, be sure that your backplane is upgraded to the level in which that's not going to be a problem. But you will eventually max out. But the beautiful thing about multicast is it's pretty rare that the endpoints are going to be the problem. It's really going to matter, essentially, then, how much your network can handle, because it's up to the network to process the data and to get it to the subscriptions. So Multicast has this beautiful, it's one less factor, right? It's one less, I mean, there are bad cables and there are bad ports on switches and whatever, fine. But it's one less factor of, hey, I'm getting inconsistent performance. You can pretty much almost guarantee that you're probably maxing out the network side and not necessarily the ability for the camera to send the streams to multiple destinations. One last thing I'll say about this. When of this kind of like pseudo education side of Multicast, when you're in a TCP unicast environment, okay, TCP UDP, the burden of replicating those packets is on the endpoints. So your P4K is operating in 4K level, right? 200 megs, 220 megs per stream. If I subscribe to the P4K 3 times, that's about it. That's all that network card can do consistently. And it probably, I would actually advise less than that, to be honest with you. And a great way to test this is open Studio Monitor twice, because Studio Monitor subscribes to NDI streams twice. I don't know why, but they do. Open Studio Monitor twice on the same camera. You're probably pushing the limits of that network card. But in a multicast environment, it's only 200 megs. That's all the camera's responsible for. Get the information on the network correctly, okay, in order, in sequence. And then it's up to the network to pass that. So a P4K in a multicast environment, theoretically, can go to the end limits of your network's ability and processing power. It's beautiful. It eliminates that problem of the performance of the actual network port on the device itself. Okay, that means that problem is much less likely going to be the issue when you're having performance problems. Okay, that ends that kind of like educational piece. I'm really sorry if that was super confusing or if it was useful at all, but hopefully that gives you a general idea as to why multicast really shines, especially in mid to large size installations. And I'm going to show an example of a 4250 multicast configuration, and then we're going to actually put cameras on that multicast configuration. But I want to bring in BirdDogJake back to this conversation because he is also running a multicast environment, and he's doing multiple AV requirements on the same VLAN running in multicast. So he's doing Dante, and he's doing full BirdDog NDI as well. So I will re-add him to this conversation, and I've got his
howdy, John.
Microphone unmuted now. So, hey, what's going on, man?
Perfect.
Thanks for coming back and hanging around.
Thanks for covering all those things. You know, it's really important, you know.
Yeah, the first thing I want to ask you, because I don't normally have is direct feedback like this, is what did I forget? Or what did I miss? Like, what's outstanding that I glazed over?
The only thing that I think that I was looking for was maybe the IGMP querier, right? Because you have your snooper that's finding those devices, and then you have a querier on the network, which you only usually want one, if I remember correctly, right? But no, pretty much those are all the main points in which multicast is required, and those settings that you're going to see on various switch manufacturers. Yeah.
Now, what's really interesting about the AV lines that have that kind of NDI stamp of approval, and again, the major one right now is the 4250, 4300 line, is that they have gone to NDI and they've come to BirdDog and they've gone to some manufacturers and said, like, what is your out-of-the-box settings? So that essentially you can turn on the NDI5 profile, which is already enabled for multicast, and you can turn on multicast on the device and they start talking multicast packets. Now, you do need to restart the device, by the way, but we'll talk about that when we talk about integration. But you can enable that function and it starts to work right away.
Exactly. That's why those profiles are so fun.
Yeah, what multicast isn't, though, is I go into my BirdDog device that's running on my Unify network or my TP-Link network, and I turn on multicast and I restart the device. That is not multicast. Your network has to be multicast enabled, which means that the last step in the multicast installation is turning it on at the device level, but you need to go through and make sure that your network is even capable of doing multicast.
Yep.
So there's kind of an assumption there that it's like, oh, you do multicast? Okay, I'll turn it on my camera level, and then they don't.
No,
see
you'll want to
multicast.
definitely make sure that you don't do that, because if you do turn on both the transmitter, right, your node, the source to be multicast, and then you turn on your receiver to be multicast without setting up that in between, you're going to run into that flooding ports packets that we went into earlier. Because the network's not going to know where it's supposed to go, and it's going to broadcast that stream everywhere.
Yeah, and packet flooding is a real thing. Very much so. Matter of fact, NDI had an issue with packet flooding with their own NDI broadcast back with like NDI 2.5 or 3.0, or I forget what it was, but they were just like, the algorithm was running so often to announce in TCP to like Studio Monitor or whatever.
Yeah.
And so the original SDK, one of the original SDKs, was announcing so often that it was causing packet flooding, and so they just dialed back the algorithm and stopped that issue. Yeah. So, anyways, that was long ago and way in the past. Yeah, and it's so good. Okay, so let's talk briefly then about let's talk about integrating this on our network. So I can put this. Let me open up. First of all, I'm gonna open my 4250 actual switch here, and we can look at the profiles. We can even set up a profile for it, but it's pretty straightforward.
In this AV interface, it gives us a direct option for multicast, and you'll jump into it. But we get to see all our multicast groups and everything that's currently subscribed, the source, as well as that subscriber MAC address that we were talking about.
Right. All right. Let me jump over to. I'm going to put this on the actual StreamYard computer so I can share the screen and we can both be still present on this show. So here we go.
Yeah, I haven't tried presenting through StreamYard directly yet.
Yeah, so if I can add it to stream like this is basically a screen share.
Oh,
and
perfect.
Then, it keeps you all kind of over on the left-hand side, and we can even make it where it's like we're bigger. But I like this.
Oh no, this makes a lot of sense. This is great.
So this is a switch. This is just kind of a standalone situation where I have one switch that's governing my entire studio. But you can actually use the Engage software, and I haven't. On Tuesday we talked about the announcement of the 4300, but they also updated the Engage software, and they announced that it would be end of June or early July. Mm-hmm. And so in the Engage software, there's actually a way to do this across your entire fleet, which is super helpful. But in this instance, we want to just walk through how to do this at the switch level. And so traditionally, you would create a brand new VLAN, and you would enable this as whatever profile. So I'm going to actually do that. To do that, we're going to go to actual network profiles. And then it's actually behind this. Why is that hovering over that? Okay. Wait,
yeah, I noticed that as well. That happened on my Switch last night, actually.
Let me see if I can't figure that out. How does that work?
All right, well, I know.
That is an interesting issue. I have yet to have.
What firmware are you on? I'm just curious because
I'm on the late. I just updated this to the latest.
To 14.
So, all right. Well, let's just create another one. That's fine. Create AV template. Here we go. Oh wait, no, I don't want to create an AV template. I want to create another. How do I get behind this? Boy, this is awkward. Stand by, everybody.
Down below. Hit the gear icon for the new AV NDI VLAN.
Oh, you're right. Okay, so video for the one that we want to pick in this instance, which is already enabled for multicast. It's enabled for NDI 5, but it's also claims to function with Dante, in which our friend here, Jake, can attest to. So we're going to hit this actual gear. Okay, here we go. And we're going to create our new actual profile. Good catch. So we're going to show this as today it's going to be our test VLAN. And I'm going to name it. Now, this is just me, okay, by the way. I'm going to name it something specific because I like putting the VLAN profile name, the number of the actual VLAN in the name, just so I know when that everything's the same. So if I call this VLAN 65, the ID probably needs to be 65. For funsies, we can change it to whatever color we want, and that's fine. And then in this instance, we are going to set this up as its own having its own DHCP governance, okay? So that IP addresses will be issued on its own when we plug into any of these ports that are on NDI 65. So the VLAN IP address. Now this box is if I'm plugged into this VLAN and I need to get to this switch, what do I type in the web? So like up here, see it's like 192, or you probably can't see that actually. This switch's interface is 192.168.1.60. That's its address on my network. So that's what I'm doing here, but inside this VLAN. So if I say 192.168, and then I'm cheeky like this, and I say 65 because that's my VLAN ID, and that's also the profile name. So this whole network is going to be the 65 network. So the way I do this, and this is totally it's subjective. You can do whatever. You can make it as confusing as you want, but I find this to be fairly easy. So I can say 65.1, or I can make it 254, you know, one or the other, but preferably either the first number or the last number in the line. And when we say that networks have 254 assignable IPs, it's generally because the first one and the last one are reserved for certain functions, and this is one of those functions. So I'm going to make this 192.168.65.1, and I'm going to set my subnet mask at WAC 24 because that's the way I believe NDI should function. This will give me 254 addresses. And then I'm going to turn on the actual DHCP server itself. Now, Jake, if you're waving and trying to get my attention, I can't see you right now. So
no, I'm not. No, you're perfect. I'm just nodding along because this is exactly how you set it up. I mean, I prefer the 65 octet or the third octet. That VLAN ID, and I completely agree.
Well, what's nice about that, and as like a trick from a sustainability and troubleshooting stance, is that if I plug in and my device gets a 65 address, I know I'm on the right VLAN, right?
Right.
So even if I've forgotten which ports are belonging on it and I get a 1 address, it's like, oh, that's my data network. Then I plug it into a different one, I get a 65 address. Okay, I'm on the right. I'm on the right port now. So the default router then is 65.1. And then here it says, where do you want to start that DHCP pool? So where do you want the IP addresses to start being issued? All right. And I don't like leaving it wide open all the way. So I typically start at 10 and then I go to 254. That's what I do. You can make this a little less if you want. Yeah. And the nice thing about this is, first of all, it leaves you 9 other addresses that are kind of never to be used. And so if for some reason you need to add a computer and you want to give it a static IP address, you give it 65.2 and you know that address is not being used, right? But I start at 10, and when I plug a device into one of these ports now on this VLAN and it gets 65.11, I know my DHCP is functioning correctly because it issued an address after 10. So there's that little helpful hint as well. And then the DNS services is basically how do we route information outside of this VLAN. I'm not going to go into that on this tutorial, and I didn't on the previous one either. But the DNS servers, you can either point this at a gateway that's actually on your network on a different subnet, which should give you internet access outside, but we'll talk about routing and all that stuff in a different video. But what I want to draw attention to here is this actual lease time in minutes. Okay, so this is how long do IP leases last when the device stops requesting one. All right, so typically a computer, if you plug it in, it's going to send repeated broadcasts to say, I'm still here, I still need my IP address, don't change it on me. Here's my MAC address. It's going to give out those broadcasts. But primarily what the lease time is about is when I take a computer or a device off of the network, how long does time need to elapse before that address becomes available for somebody else? Okay, so you can make this number whatever you want. Typically, guys will make them at least, a 1 business day. In this instance, this is, if we have 24 hours, they've basically given you how long? Or sorry, divided by 60. So where are we here? Let's do some simple math. To 240, that's like what, 3 hours or something like that. So 4 hours. It's a 4-hour lease. You could double this to make it an 8-hour lease, which is your typical business day, right? Or you could make it like 7 days if you want. So you could do 60 minutes times 12 times 7 and put in, and I believe that's 10,800 if I'm not mistaken.
Yeah, it's 1440 per day. So
yeah, there you go, 1440 per day. So you can put in some massive number and hit apply, and it would reserve that. So here's the instances. I go to my church congregation twice a week and plug in my laptop. I want it to have the same IP address issued, most all the time, and for that lease not to expire. And I'm not having big turnover on that network, but some people do come and join and like bring other devices. Well, you can make it a 7-day lease, meaning that it will remember your MAC address and the IP address it assigned you, and will keep that lease available for you in most scenarios for basically a week. And then if you don't show up for 7 days, it'll issue that address to somebody else. That is essentially what the lease time is. The other piece is modern networks will allow this time to elapse, and then will re-broadcast to that device and say, are you still here? Do you still need this address? And if the camera's on, it will say, yep, still here, still at this MAC address, and it will renew the lease. So this doesn't mean that every device that's been on your network for 7 days will get a new IP address. It also doesn't mean that if for some reason you didn't show up within 7 days, you would get a new IP address. It's just saying, if you're having high IP turnover, how long do I need to wait before I'm allowed to issue this IP address to somebody else? So that's traditionally what the lease time is. And then we hit apply. Now, on a 4250, you're going to see this little warning. It says, we actually really recommend you at least list one DNS server. But in this instance, we are not talking to the internet on this VLAN. Okay. And then it creates my profile right here. Now, I'm not associated to any ports because I didn't highlight any of them when I did that. But the way you do that is we can go in here and say edit. And we can tag whichever ports we want. So we just put check marks next to them and hit apply. And then it would push those ports onto that VLAN, give it about a minute, and then plug in your first device to it and see if it comes up with a 65 address. That's how you set that up for the NDI5 profile. Now, how does this now coincide with multicast? And this is where I'm going to bring Jake into this conversation a little bit, because our profile is set up. So what do we need to do now to get this to work with to make this a multicast network?
Well, what's fantastic about that AV profile is that Netgear automatically handles that IGMP snooping and query selection and election, depending on what switches you have. And if you've plugged in multiple switches, as you have, John, and so have I and all of our other customers, you see that we have an auto trunk available as well. So there's a lot of things that Netgear is doing to assist us and our teams and everyone using our gear, right? Mm-hmm. So the next step, right, because the first step was to get multicast gone.
Right.
Let's start editing our devices.
So yes, so now we want to go over and we want to start adding our devices. Let me pull up a...
And we're going to go from BirdDog source to decoder, right?
Yes. Yeah, we can go to BirdDog source to decoder.
Because there's some conversations to have if we're going to a computer that's receiving those NDI streams and what that means.
Right.
For all the applications like cam control and studio monitor and multi-view and whatnot.
Right. So this is the P200, and I hesitate to use a camera that I'm streaming to in vMix because it could cause all sorts of issues here. Mm-hmm. But this is
you'll be okay.
This P200 camera. Jake will be here to save the day and keep the conversation. This is a P200 camera that I'm using for the actual show. It's a little different angle, P4K, P200. And nice. That is this camera, which is functioning in TCP environment right now. And that's fine. It's interacting with vMix just fine. It appears to be not having too many issues. But I want to switch this over. This camera is plugged into this 1.60 switch that I've been using right here on the that we've been customizing with my new VLAN. Now, a little bit behind the scenes is I've got the whole network functioning on a multicast level as well, and so we're prepared to do this already. But I'm going to go into this this web UI, and first we got to put in our super secret password and get past the actual dashboard. And the way that we do this is we can go over, we want to make sure that all of our settings here are correct. So I've got my local name, I've got my DHCP settings, it's receiving an 81 address, that's great, a 1.81 address. And then down here under the actual network setting, it says preferred transmit method. And from here, I want to change this to multicast. And this is, remember when I said that Netgear has done their due diligence and talked to the NDI world about this profile and made sure that they were aligned with the expectations of networking for multicast, well, they've actually enabled this to function with these default settings. And these default settings come from the NDI SDK when we talk about multicast. And so these came from NewTek. And then the specs for the actual NDI 5 profile for multicast came from NewTek. So they're all talking the same base language. Now, your IT department may have a different flavor switch, may believe in Cisco only, may believe in various, networking ideas and beliefs.
And importantly, maybe have a specific multicast subnet that is not the default range. So,
correct.
If you guys look online and see what the default multicast ranges are, multicast is used not only just for local switch distribution, but for internet protocol, for getting packets all across the world, right? So there are specific addresses that we absolutely cannot use because they're used for other things.
Right.
The default starts at 239.255, so on, so on. So if your IT department says this is the specific subnet that we want these multicast addresses to be on, that's when these start to get changed.
Exactly. That is when you would start changing these if your infrastructure requires it, because you're using specific ones because the other ones are occupied with something else, or like Jake said, there are certain ones that you absolutely cannot use. This is the default stuff. And
it's
so for the 4250,
from BirdDog, from
exactly
everything, makes it super easy to get up and running.
Yes, super simple. So we can change it to multicast, but I'm still actually running in TCP. And as many of you know, when you hit apply and then we go to the dashboard, we probably need to restart this device to get it functioning correctly in the now it's going to change its network mode without doing it, but I strongly recommend that you at least reboot the NDI chip to do this. And so my video just froze in vMix. Glad that it didn't dump vMix. But video frozen vMix, restarting, device mode is now in code, and check this out. Network mode changed to multicast.
Awesome.
Now, I am now streaming again. My 200 is now streaming on this network again, so that feed has come back and is live. And the report is that my computer is functioning, or I'm sorry, that the P200 is functioning in multicast. All right, now, the question might be, okay, great. How do we verify that? Well, you can do that in Wireshark, and I have a video on my BirdDog John page that talks about Wireshark. I don't know if I chopped it up into a keynote or not, but maybe I'll do that next week. You can actually run Wireshark and see the multicast packets coming out of 192.168.1.81, which is what this camera is. And the easiest way to do it is run Wireshark and open Studio Monitor, subscribe to the stream from the camera, and then run Wireshark, and you will see that traffic moving across the multicast IP ranges. Okay, that's how you know. And the packets will be listed as UDP. So UDP, and you'll see, let me jump back here, sorry. You will see the, network. You will see an address that looks something similar to this, okay, being issued to the camera, and that subscription will be, you'll see those packets moving. That's how you know that you're outputting multicast packets onto your network and that somebody is subscribed to it correctly. Okay, so we got our
about
camera.
That subscriber quickly, right? So pulling it into your vMix, right? So your vMix in Access Manager, so this is where those computer devices come into play. Until that NDI receiver decides to pull that multicast subscription, that P200 is going to be doing a unicast stream to it.
Right.
Because the receiver didn't request to receive it on its multicast stream. So that's one thing to triple make sure that when you're doing any software NDI applications is that NDI Access Manager multicast is enabled.
Right.
Right.
Yeah, good point. And I have that over on.
Yep.
I've got a PC on this side and a Mac on this side. I'm running the show off the Mac and like sharing. Anyway, so yes.
No, totally.
So
so that's something definitely to make sure if we're going to be jumping into software NDI applications. But in either case, you can see those multicast subscriptions inside the Netgear M4250.
Right. Okay, hang on here. Let me... Okay, I've opened Access Manager just so we can kind of talk a little bit about this.
Yeah.
Jake, you'll still be on here. I'll make myself full screen so I can show... Sure. Sorry, I got too many options here. Okay, this one and this one. Okay, so if we jump over to my screen share here, and this is the actual Access Manager stuff. So you're saying, well, what are you talking about? You have to enable it in Access Manager.
So we go over to the Advanced tab, and then there's a multicast drop-down, and looks like you already had it enabled, right?
Yep.
So
you would check this. This box would be unchecked by default for Access Manager. So you would enable it and it'll say like, "Hey, please know what you're doing here, and please talk to us if you don't." And then you'd enable it and check this out. The defaults are already filled in here as well.
Exactly.
As you know, again, so unless you're instructed by your IT department to change these, this would be the defaults that are set across the fleet.
Something to note, guys, if you're using Access Manager on a Mac, they unfortunately do not pre-populate the default values in there. And
oh, interesting.
Actually, John, I found a bug in yours right now. And I think this was an old, this was a NDI bug. Inside Access Manager, your subnet mask and your subnet are switched.
They're swapped. Yeah, they are. You're right.
Yep. So let's make sure we change that.
Yeah, this is 5.5.0.0, I think.
Yes, that was the one that it was in, was switched.
Okay, so everybody update your NDI tools so that you don't have that issue.
Yes. Okay, so let's actually make a note about that right now, because I know that there are a lot of locations that have older NDI tools installed that can't obviously upgrade just because there's a new bug fixes that come out or whatever it is. So please, if you guys are not updating and going to be looking at multicast for software applications, look at NDI Access Manager and make that sure that that's correct.
Yeah. I think that is true. So I opened Access Manager on a Mac, and it's also true.
Or is it
swapped?
Flipped? Oh, is it really?
On what version is this? Oh, good catch, man.
Because I tested it on my new M2, an Air,
this is
and
version
it
2.0.
wasn't even listed.
It didn't even fill it in.
Yeah.
Interesting. They are swapped on this one too, so that may just be a programming oopsie when they were doing an update.
Yep.
Okay, good catch. So if you're wanting, yes, okay, great catch, great note too. So if you're running Wireshark and you're wanting to see the multicast packets coming across to Studio Monitor, you definitely need to have that enabled inside of Access Manager. And remember, when you check the box and you fix the form, you have to hit OK in order to apply those changes to the NDI library that are stored. The changes don't take effect until you basically close Access Manager. But what it does is it's changing the NDI libraries.
And the program that's being used.
Exactly.
So if Studio Monitor is open while you make that change to Access Manager, you have to close down NDI Studio Monitor and open it back up.
Yes.
I personally like resetting my computer. So that way, because I have screen capture that starts up, I have all my BirdDog devices and any NDI streams that automatically boot up at the start of the computer. We want to make sure that those are also in multicast.
Yeah.
Hello, IT. Have you tried turning it off and on again?
It's kind of a joke, but
that's the one.
We do recommend turning it off and on again quite often. So it's anyways. It's one of those.
You'd be surprised how much that helps.
How much it solves. Yes. Okay. So then you can. So now we can see that the multicast packets are coming across. We can do this in Wireshark. So now we got to get this to a decoder. So I'm going to open up. I'm going to share another screen here. I've got my BirdDog Play, which is running my multi-viewer pro output for all of my cameras here in the show. Now, you're not going to be able to see that, but you will be able to see the interface for this BirdDog Play. So right now we're running this play. It's set in TCP. It's working just fine. I can see everything in my on all of my cameras so far, which is great. So let me jump over there. And again, here we're going to log in. I've actually already logged in, and we're going to go over back to the network. So same situation here. I'm running this in DHCP. It's been given an address. The BirdDog Play shows me the address when it boots up, which is super handy. And, my MDNS, my short name for the actual product. But here we go, back to NDI network settings. We have the actual TCP option that's selected, so we can do this in multicast. Now, you'll notice there's no multicast settings to change here. Jake, do you know why that is?
No. Let me check my play.
So I think that this is just because it is only subscribing to the so the configuration side happens at the encoder and the network level, but it doesn't happen at the decode level. So it's just subscribing to multicast streams.
Yes, you're 100% correct.
Yeah, it's not generated.
The preferred receive method for multicast is only putting itself as a multicast subscriber on that address, so you don't need to specify which subnet prefix and mask it is, because it's going to be going through the network to find that device and then have that subscription. Yeah,
exactly right. So we, as Jake says, we always we like to turn things off and back on again. So I've changed it to multicast. I've hit restart. It is rebooting right above my camera. Let it come back, actually start functioning, and then we can actually refresh this page. Let me see if it actually changed. Yes, it did. Okay, and we're listed here. Now, give the dashboard a few seconds to update. I get impatient, so I don't do that. But we are functioning now in multicast. And again, great to reboot the device. Great to okay, so remember what we said. Device restart is NDI chip reboot. And then system reboot is actually starting the whole boot up process all over again. And that's the same for all of our products across the fleet. And then pulling the power on it is a full-on power cycle. Okay, so there are three different things. You can do an NDI chip reboot. You can do a baseboard reboot, which reboots the baseboard and the chip. Or you can do a power cycle by pulling the power on the device and plugging it back in.
We give you all the options.
Yes, exactly. And now the decoder is running in multicast, my encoder, my camera, or whatever is running in multicast. My computer is able to see this stuff, and we could actually use Wireshark to see if the data is being sent over. You could snoop it if you wanted to, but see if the data is being sent to the play as multicast with multicast addresses. But that is basically confirmed in this instance. And on a 4250, I mean, we've been chatting for an hour, but that took a whole lot less time, and with explanation, by the way, than it would if you were building this from the ground up. And so beautifully, Netgear has taken care of a lot of that work that you have to do to get multicast functional. And you could watch a YouTube video like this one, for example, and pretty much figure it out for yourself if you're running the AV line from Netgear. So, again, I can't speak highly enough of them. And I'll even give them a secondary shout out that if you do have questions, they have a dedicated email for people who are running. I was
talking to them yesterday. I needed their assistance.
Over IP. Yep. This is from my experience, they're very responsive to this email address, and so they're becoming very, very popular in the AV realm. And with the introduction of the 4350s, that is equally as exciting. So I'm looking forward to that. Okay, let's officially kind of wrap up the how-to function of multicast and how to get that going, and also a little education piece. We will get back to the chat. Jake will hang around as long as he can. We'll answer any questions, and then as a sidebar, we can talk a little bit about Dante running parallel with multicast kind of post-recording. So let's do that next. Let's jump back to the chat, and let's do that next.